Okay, we're going to solve some exponential equations. So again, we studied exponential equations just a little bit ago, where we have a base that is a real number, and then the exponent has something, an expression containing x. So there's a couple different ways we can solve exponential equations. First one is if there's only one exponential term, we're going to isolate it just like we would, say, x, and then use that definition, and I'll write that definition again. So if we have log base b of x, if we call that y, that is equivalent to b to the y equaling x. Okay, so we're going to try and use this definition over and over and over. So here in this problem, if we want to isolate x, we're going to multiply by 2 on each side first. So we get 5 to the power of x is equal to 8. Okay, and now at this point, we want to think, okay, well, what power of 5 goes into 8? And that should come to nothing should come to mind easily. Okay, so what we're going to do is go from exponential form to logarithmic form. Okay, so converting this to a logarithm, I'll have a log base 5 of 8 is equal to x. Okay, and at that point we're done. So you could evaluate this, but it's enough to just stop here, and we can say the solution set is, and then we can use curly braces, log base 5 of 8, period. Okay, and that problem's done. Okay, now if we have two exponential terms of the same base appearing, this is really what we were doing towards the beginning when we introduced logarithmic functions right away. We want to set, if the bases are equal to each other, then the exponents have to be equal to each other. So that just means, well, x plus 1 should equal x squared minus 3x minus 4. Okay, and now this is just a quadratic equation which we should be able to solve. So let's see, moving everything over to this one side, I get 0 is equal to x squared. Subtract, I get a minus 4x. Subtract another one, I get a minus 5. And then factor x minus 5, x plus 1. Okay, so I get x is equal to minus 1 and positive 5 after I solve that. Now technically, and I skipped it up here, you should check your answers, but with exponential functions, they will always check. When we get into the logarithmic equations, that's where we actually do need to check. So the last step, again, to conclude this thing, we should say the solution set is, and then write -1, 5. Okay. Last problem. Now if we have two different bases appearing, this is where it gets a little extensive, but it's still manageable. We're going to log both sides, essentially. And what that means is that we're going to apply a logarithm of our choice. I prefer natural log. You can use a common log if you want. So I take natural log of one side, and whatever I do to one side, to maintain equality, I also have to do to the other side. So natural log e to the 2x. Okay, and from here I'm just going to use the properties of logarithms. And let's see, I'll keep the same color, I guess. By the power law, I can bring the x minus 1 out front, and I'll have a natural log of 3 after that. And this is equal to 2x times natural log of e. Okay, but as natural log is base e of e, that just washes out, and that's just 1. So really, if I distribute here, I get x times natural log of 3 minus natural log of 3. This is equal to 2x. Okay. Now to solve this, we have to think, well, okay, I have x's on both sides. Typically when I solve an equation, I want all the x's on one side. So that's exactly what I'm going to do. I'm going to get everything that's x to one side and everything that's not x to the other side. So doing that, I get x ln 3 is minus 2x is equal to natural log of 3. Okay? And at this point, I have an x in both terms. I can factor it out. Natural log of 3 minus 2 is equal to natural log of 3. And then lastly, I have multiplication here, do division to get x alone, and I get x is equal to natural log of 3 divided by natural log of 3 minus 2. Okay, and then so essentially this is all we have to do. We can go back and check it, and you're more than welcome to put it into your calculator or Wolfram Alpha and get an approximate value, but I'm going to omit that and just stick with this exact answer and just write the solution set is, open a curly brace, bad curly brace, natural log of 3 over natural log of 3 minus 2, and curly brace, period, and we're done. Okay, so 3 basic techniques on how to solve exponential equations, and we will look in the next video on how to solve logarithmic equations.